Hi, we'll be taking a look at cleavage and minerals here, and this is a piece of gypsum. And I'll be demonstrating how it cleaves and the three different directions in which it cleaves. Here's a closer look at that piece of gypsum, and it has nice, flat, smooth surfaces, as you can see. And what I'm going to do is see if I can split it along that particular surface. And I'm not going to use a hammer. I think I can probably do this just with my fingers. All right, there, it cleaved. That's a perfect cleavage, producing nice, flat surfaces guided by the atomic structure. All right, let's take a look at the thinner piece here. See if I can't cleave that one again. It's cleaving coming off in a bunch of little pieces here. Here's a small piece right here. So you can see it does break again and again. I do have a knife here, and I'll slide this along the cleavage direction. Produces a little better one. All right, and if I had more patience, I could probably split that again and again and again, so that you can see that gypsum has cleavage guided by the atomic structure. But looking at this piece right here, I noticed that there's a little line right across there. That's an incipient cleavage plane. I'm going to break it along that line. However, I also want to show you another physical property of gypsum, and that it is that it has flexible sheets. So I can take this one right here and apply some pressure to it, and you can see that broke along that incipient cleavage plane there. But in this piece right here, you can see how it's bent. All right, so that bends a little more. Gypsum is flexible. All right, continue to break it here. Here's that broken chunk here again. So the cleavage directions that are produced so far are top and bottom, this side, and the side my thumb is on, and again over on these two sides. So that's one direction, two directions, three directions of cleavage, and they'll repeat themselves. Now I already repeated it along the flat direction there that produced the thin sheets, but I can reproduce it in that direction parallel to that side. So I'll take it, it bends a little bit. All right, so that's the cleavage in that direction. And along this direction here, parallel to where my fingers are right now, there's one, another one, maybe one more, yeah. All right, so you can see these are all cleavage fragments here. Gypsum has perfect cleavage in one direction, producing these thin, flexible sheets, and two good directions of cleavage otherwise. All right, so that's gypsum. This is a closer view of all the little fragments that were produced by that process. All right, this is all the gypsum fragments. Look at those out of the way. Bring in this one piece right here. What I want to show you here is the difference between the cleavage in gypsum compared to the cleavage in muscovite mica. So let me cleave this one here again, get a nice thin sheet. Okay, that broke. Nice. And I do happen to have a piece of gypsum or muscovite mica over here. And you can see there is some similarity. Now there is a big difference. Gypsum has cleavage in three directions and mica has cleavage in one direction. But the other thing I wanted to show you was that gypsum has flexible sheets. So you can take it and you can bend it, and if I bend it too fast it'll break, but it does bend and it stays bent. Whereas a sheet of muscovite mica, you can bend it, but it'll snap back. Muscovite mica is elastic. It bends, but then it snaps back. Now this is a pretty thin sheet of mica here, and it would be difficult to cleave. But this is a nice flat surface produced by cleavage, as is the opposite side. And along the edges here, instead of producing straight surfaces, it breaks with an irregular fracture, unlike the gypsum, which has more cleavage directions. Okay.